This will be Clojure and 5 rules of data. So let me start with a little background on me. I got my degree in computer science at OU in 2005. And I've worked in JavaScript. That's what I started in, JavaScript, PHP. After a couple years, moved on to Rails, and then I've been doing Clojure and ClojureScript pretty much exclusively since about 2012. And so kind of to establish the rules of the talk, I always try to have a goal when I give a talk. It's either to teach someone how to do something or, try to encourage them to do something. And I try to make sure I have something for both brand new people and people who are, even more senior than me. So thinking about this, it was like, I didn't want to just do a Clojure talk, which is like, hey, here's how Clojure works. Because most people, Clojure is not used, as widely as a lot of languages. So I want to give you a reason to use it. So I want to kind of talk about the values of Clojure and why you might want to use it. And so we'll hit some Clojure in there, but mostly it'll be about the concepts that Clojure kind of brings out. As I'm talking, I'll use data and values are interchangeable. Both of those words I'm using kind of interchangeably. And one big thing is values don't change. Right. So like the number 2 is 2, and if you add 1 to it, it becomes 3, but 2 is still a thing, right? And so changes over time are really just creating something new. So when I say a value, that's something that doesn't change. And then I'll use Clojure and ClojureScript. Most days I write ClojureScript, which is Clojure compiles down to JavaScript, so it's a hosted language. That's ClojureScript. Clojure, it compiles down to Java. And then there's Clojure CLR too. But I use those interchangeably, and they're mostly interchangeable unless you hit some of the specifics of the host language. Right, so if you're in the browser, there's specifics to ClojureScript that don't apply to the backend with Java and vice versa. And these are 5 rules. These are not the 5 rules, so don't keep track and say, oh, well, you didn't hit this one point. This is something, is like, yeah, I'm not going to hit everything, right? So this is just 5 things that I want to focus on, and ask questions at any time. I'm trying to leave enough time. There should be enough time for us to have, plenty of dialogue about this. But just ask questions at any time. So getting started, who is like, I'm either like an absolute beginner at functional programming, or I'm pretty new to it. Do we have anybody like that? Okay, cool. Who would say like, who uses functional programming like on a regular basis and gets paid to do it? Anybody? Okay, a few of those. Okay, cool. Who has ever used Clojure in any way at all? 1? Okay, awesome. Cool. Lisp in general. All right, there we go. Okay, cool. All right, so we'll talk about Clojure syntax. Right, so the first line, it's adding 1, 2, and 3. So you have the parentheses, which define a list, and the first argument to a list is the function. Everything else is arguments, right? So the function is the addition, and then arguments 1, 2, 3, and then you have comments with a semicolon, and so that's kind of how I'll express the result, right? So you add 1, 2, and 3, you add those together, you get 6. Next, you have a map. Hash map is kind of, a lot of people will look at that like JSON. They'll see that. It's just a map, a key value store. And so we define a map, and it has, the first key is the keyword A. So keyword is you can think of it in a lot of ways as a string and just kind of a special type of string, but most of the time you'll see it as keys in something like a map. So you have the key A and the value 1, and then you have the key S, and the value of it is a string XYZ. And then you have the key of 7. So hash maps, anything can be a key, anything can be a value, and they don't all have to be the same, right? So we just set the key as 7, and it has nothing to do with index, it's just the key, right? And then we have a list, which is the same as what we had up front, but we have a quote which says, this is a list of data, do not evaluate it, right? So it doesn't matter what's in there, it doesn't have to be a function first, this is just data, right? So it's just a list with A, B, and C, and A, B, and C are symbols, and my map is a symbol that references the map as a whole, and these are just symbols that we've defined, and we haven't said exactly what it refers to. So then we're going to associate a value into my map. So assoc, my map, and then the value, the keyword B. So that'll be our key, and the value will be this vector 234. So vector is kind of like an array. How you can think about it, it's indexed. And so when you do that, you'll get this new map with all those keys and values, A, S, 7, and the new value B, or the new key value B in that vector. But when we look at my map has not changed, right? So even though we, quote unquote, changed it, we created a new one, the original didn't change. All right, so that's a really big concept. So before we get into it, let's talk about some of the old rules. Like, what do we do now to kind of work around some of the limitations I'm going to talk about, right? IDE code completion, right? Okay, you're in Java, and hey, what does this object do, right? I want to start typing, and the search space is so vast, I want you to help me with that. Right. Encapsulation data hiding. Right. It's just like private, protected. You can't see this. You can't touch this. Those are things we do. And the underlying thing is, I think these are bad rules, and so I'll get to why. Out-of-band communication. Right. JSON. How do you encode a date? Well, it depends, and you have to go ask someone outside of the data. Right. You can't look at it and say, oh, this is JSON date. I know that it's month, day, year, because it could be year, date, month, whatever. So out-of-band communication around it. Naming conventions, right? That's kind of, again, the IDE of we're going to have a bunch of names, so let's always try to make sure we name them the same way. No values, like we'll get into that, but sometimes it's really hard to actually get the value, right? It's like, well, here's a value, here's the date, and I can't really talk about the date because it's an object, right? And I can't say, give me this date and I want it to never change. Well, you gave me an object so it can change. So so then I started doing like freeze, and well, does freeze all the way down? Is it deep, right? All these things, because I can't just get that as a value. And that's tied with the fact that data and behavior always are together, or not always, but are frequently together. We have to push all of our changes at once, right? Like, hey, I better make sure I do this and try to make it atomic because I need to make sure a thread doesn't jump in there between me, right? So I have to think about how do I batch this together and make sure it goes all at once. And then, hey, I'm going to pass my object to this function, to this method. I wonder what they're going to do with it. I better work around that, right? So these are all the, these are rules that we have as we're programming to protect ourselves from different things, right? So we'll start talking about what are the new rules. Ooh, I'm going to have to speed up. Okay, separate data and behavior. So in Clojure, this is a date, right? It's an instant. So there's date, time, and this is data, and everyone knows what it is, and your programmer knows what it is, and it's just a value. All right, versus JavaScript, you say new date, and you get a date which comes with add month, get time, right? Those two things are together, and how in JavaScript do I get the date apart from that? You have to call get time, or to local time or whatever, and it gives you a number, which is not a date. Cycle is a function in Clojure that just takes whatever vector you give it and creates an infinite, basically repeating list that cycles through whatever you give it. Right, so I use this to say, the SpongeBob meme where all the letters are alternating, right? You apply this, and you can grab all the functions you can apply to each character in a row and pass that around. Right? Versus in JavaScript, when you try to do this, to lowercase is tied to a string object. So I have to wrap that in a function before I can pass it around. So higher order functions require me to do more work because the behavior and the data are tied together. And they don't have to be. Right? There's no reason that lowercase has to be tied to a string, except that that's the way it's designed. Right? So generally speaking, we can and we should design our data and our behavior separately. Right? So we can think about the data of the system before we start talking about how we interact with it and what we do to it. And when you put things together in objects, you have to think about those things together, or you're encouraged to think about those things together. Right. Rule 2, use a simple data API. So this is one of my favorite little snippets from slides from Rich Hickey. Most of my talks, all my talk, you can just go watch Rich Hickey and you'll get a better version of it. But he's talking to Java developers, and so this is HTTP servlet request, just an object, but it has all this stuff to get an object. Right. So who remembers all that? No one, which is why you have code completion. Right. And it's not even consistent because you have remove attribute, set attribute, but then you also have set character encoding. Well, why isn't that an attribute? Well, I don't know, right? And that's why we use Stack Overflow so much, because I have to search to figure out what design decisions you made, because I'm not saying it's arbitrary, but you made it based on data that I don't have, and I can't figure out. There's no way for me to look at this and understand why this is the way it is, right? So if we look at this, really, it's just a map. It's just data, right? Whenever you send something across a wire, you're not sending this, right? You're just sending a bunch of data, right? So what he says is, how do we get this and somehow make it into this? Right. So it's just a map, and you can inspect it. You can say, hey, what is a query string? It's this. Right. What are my headers? It's another map. Right. This is just data. So when you have just data, it means you can use simple functions, right? How do I get the request method? Get request method, right? Get is a function that works on all maps. Then get whatever the key is, and it gives you the value, right? How do I get the server port? Get server port, right? There's no special language. Versus here, how do you get the server port? It's probably get attribute, but there may be a get server port specific method to it. All right. So when you have simple functions, it means you can reuse the same language around things. It means you're focused less on the tool, right? We're on the domain. Right here, we're thinking about the data of the request. Over here, we're thinking about how the request is formatted, which is not our problem. That's not what we're getting paid to do. What we're getting paid to do is fix, actually program, not play with the tools. And again, we're making less guesses about how it works because everything's available and we're not basing it off of the decision that someone else made somewhere over there. Good or bad decisions. The real thing is I just don't know, so I got to go to Stack Overflow. Like, that's one thing. Since I started programming in Clojure, like Stack Overflow, how many of you guys would be comfortable programming without the internet, right? How long would you be like, oh no, I need the internet? Like, I program without the internet all the time, right? All the time, because it's like get, assoc, reduce, flatten, right? All those things, I do it all the time. I got a map. If I have a question, I look at the map. So, and I'll reuse this because, I love it. JavaScript fatigue, part of that is because you have to learn a new language all the time, right? Oh, how does this object work? Well, I got to go learn the language for that object. Well, how does this object work? It's a completely new specific language to that object, right? Versus in Clojure, it's get, assoc, flatten, reduce all the time, and you just learn it once, and then you just get on with your day, right? And so it's very stable because when you write those functions, they're done. As opposed to, hey, we came up with this new thing that does this new faster, except the arguments are flipped. Which one am I in today, right? Am I in Lodash or am I in underscore, and which one matters? Yeah. So, rule number 3, data is safe. JavaScript is awesome. People do great stuff with JavaScript. So, it is fun to make fun of each other, but it's all in good fun. JavaScript's great. People have done really great stuff in JavaScript, okay? So, always throw that caveat in. Data is safe. So if your data never changed, what would you stop doing? And what would you start doing? Kind of question, right? And so I kind of hit some of this in the introduction, right? If your data never changed, you stop asking certain questions. Is this thread safe? Like, well, it can't change, so it really doesn't matter who can access it, right? If it can change, I have to make sure I protect access to it. If it never changed, yeah, sure, you can see it. You can look at it, you can get a copy, whatever. I don't care, and I don't have to synchronize with you. Sure. I just no longer worry about that. If I pass this object to a function, what are they going to do with it? Well, I guess I better create a copy and give them that copy because I don't want them to do certain things that I'm not expecting. Look, here's a map. It can't change. You just have at it. You want to make maps keys and have super deep and nested maps and, divide by 0 in the middle of that, that's fine. I don't care. That's your code, right? It doesn't affect mine. I better make this private. This drives me crazy when I have to interact with JavaScript libraries. And it's like, oh, well, we put this in an iffy, so it's protected, and it's kind of like a module kind of thing. I'm like, I need that thing. I need that. And now I spend all my day unbreaking, pulling apart what you did, and that's not what I'm getting paid to do. My customer does not care about that at all, and I have to do that. And the thing is, well, I don't want people to change this because, blah, blah. Look, here's a map. You can do whatever you want. I don't have to worry about it, right? Stop trying to tell me or predict what I'm going to need this for. Just give me the thing and let me do what I want. And it's really hard to do if you're worried about people changing it. SQL, this is another one because, my my last contract, I had to work with MySQL after working with Datomic for a while, which is from Rich Hickey, Clojure guys. I have to go get the data, and when I go get the data, if I don't get it all, it may change, right? So I better build up all of my queries and shove them over the wire and get it all back, right? What Datomic does is it says the database can be a value, and you get a point in time. So I give you the database at 11:30, and you can query that database at 11:30 all you want, and it'll never change, right? So I can go get data, I can pass the database as a value to the function, and I can just keep querying it, and I never worry about what anyone else is doing, right? It is fabulous when you do that, and it's really hard to put into words how freeing it is to do that. But mostly, when your data's safe, your brain cycles are free to think about other things, all right? Normally, I spend time protecting, and there's always this running thread in my head of what's going on, who's around me, who's touching what, right? That thread is killed. I don't waste time thinking about those things, mostly, right? There's always going to be interactions with mutability around the edges that you have to think about, but most of your code, you're just not thinking about that. Rule number 4, use data everywhere. And everywhere, I mean everywhere. Application state, put person, name, Boston, right? Don't use jQuery to jump into somewhere and say, hey, what is in the DOM right now, right? One of the things when I started programming ClojureScript that I never really realized is it's really hard to ask questions about your UI, right? Is this menu item open, right? What's on the screen right now, right? And I was so used to going to, and if you want to ask those questions, you got to do a bunch of work to figure that out. Just put it all in the application state, right? If I ever need to ask a question, I know where to get it, right? Just put it in the application state, and it's data, right? And we know how to work with data, right? Get, associate, reduce, right? All right, we're going to spend a little bit of time on this. Use it as code, right? So this is where the Lisp is awesome in that our code is data, right? So we'll walk through this. This is effectively a macro. So you start with code, right? And let's say I just hate the function being at the front, right? For some reason, that's a thing. I want that in the middle. People say that, right? So 1 + 2, well, that's not legitimate code, right? It's legitimate data, but it's not legitimate code. So we have a list. We just break it apart, right? The first argument, the first argument is an argument. The second argument is the function. The third argument is another argument, right? And then we just swap the order. You can ignore most of that syntax, but we just flip the order, and now we have a valid function, right? So what do? We had code as data, we manipulated that, and we have more code, right? So all of this is data. Everything on the screen is data, and it's also code, right? So what that means is there's 2 programs that we write, right? And most of the time, we only write one of them, right? We write our code, we run a program which compiles it, and then we run our code during runtime. Right? So that compilation process, most of the time we have very little access to it. Why? Because you write something like Java and it converts into an abstract syntax tree, and then that runs. Right? So what Lisp does is it says, hey, when your code gets compiled, you can run code right there. So you run code at compilation time, which changes your code, and then your code runs at runtime. And so that's effectively what a macro is. And so that's probably the most mind-bending part of Lisp, but the main thing is your code is data. We love data. We know how to work with data, so you can transform your code all you want. Transform your code before your code runs, and then run your code. So you probably have to read up on that one, but effectively our code is data, and we can change our data. All right. Serialization, right? Hey, I want to send this over the wire. It's just data, right? I want to send a date over to you. Okay, I know how to do that. Right? I want to send a map over to you. I know how to do that, right? It's just data. There's nothing special about it. It's just data. So serializing it, putting it in the local storage, right? Like, oh, I have a date, and I want to put it to local storage in JavaScript. What do? Do you convert it to an int? Do you put the string there and have to parse the string back, right? Those are questions that we continually have to ask when we're doing serialization. We just don't have to worry about that. How about SQL? Who likes combining strings and manipulating strings and trying to do that? Anybody love that? No. Why not just have your query language be data, right? Right. This is a vector with keywords and symbols, right? So what this is this is Datalog, the query language for Datomic, and you say, hey, find the title where every movie release title in 2019, right? And it is awesome when you have that and you're just combining, right? Like I had to write something that says, use this data, what was the query I wrote? Find some random set of attributes. I don't know what the attributes are going to be, right? So I have to find all those, and I'm going to give you a query and say, I may or may not give you limitations on it, right? Filters, right? And so it's like, okay, well, with the string, I have to make sure I've already put the or there. I got to make sure I got my spaces right. And I'm like, and it's just, if you've been there, it's a nightmare. But this is just data, all right? How about representing the system state, all right? What is the state of the system? Is the DB initialized? Is my Elasticsearch cluster initialized, right? Just put that in a map, represent it, build this when your system starts, and then everyone has access to what they need, and you know the state of your system, right? And again, just data. HTML, right? Just vectors, and this is pretty trivial to translate into actual HTML, right? So build this up as your return, and then at the very end, a little flip that flips it to valid HTML, right? So you're working with data the whole time. So every single thing all the tools you use are applicable to everything we just hit, all right? So data is the ultimate source of code reuse, right? In college, it was like, you get an instance, right? We make classes because it's reusable. And I was like, okay, cool. Like, this is an animal, and this is a dog, and this is a cat, so you can reuse this. And it's like, okay. And then I never, ever, ever saw that actually happen in real life. Like, I just never saw, this thing I used over here in this other project, I can just grab that class and just do a little bit. And so I didn't do a ton of Java programming as a professional, so, throw that caveat in there. But Clojure, I just find so much value from the API that I learned up front, right? The thing I learned 6 years ago, 7 years ago, I'm still using every day, and I use it all over the place, right? And so to me, that is the real code reuse, when you use the same language all over the place, and you don't get specific languages for each thing you do. And then rule number 5, let data flow, right? So everything I do is web-based, so it always starts with a request, right? The request comes in, it goes to the router, then it gets the handler, you generate some HTML, and then you generate the response. Right? This is all just one big data transformation. Right? That's it. Right? So you get the request. Remember, this is what a request looks like. It's just data. So you get the request. If you put your system state as data, you just merge those two things together, and then for the rest of the time, you have everything you need, right? So then, okay, the router is just a map of the request plus the state, which passes it does some transformation, passes to the handler, right? The handler does a transformation, figures out whatever data is needed from the system state, passes it to whatever handler is going to manage generating the HTML, and then you generate a response map, which has HTML in it, and then you give it to the front end. If you're using React, you have your HTML data, you give it to React, and React handles the messy bit of turning this data into valid DOM, right? It's huge, just one big data flow, one big data transformation, right? And so if you think in data, then all of a sudden this is like, oh yeah, this is great. Because most of that is all pure functions, right? Most of that I just don't worry about what's going on outside of the world. So why Clojure? Everything I'm saying, is not, Clojure is not the only one that does this, right? Lots of languages do this. Well, the big one is Lisp. You can't do macros unless you do Lisp, right? Right. It's always some version of Lisp that gets you to doing macros, right? Because what is Lisp? Lisp is I can control the data. I can rewrite my program, right? And so you have things like Elixir, and I'm going to talk about it, even though I don't really know Elixir, but I went to talk one time. So, but they have macros, but you have to do some translation into the abstract syntax tree before you do the macro. And it's like, oh, well, we have macros. You're like, you do, and you basically have a poor man's version of Lisp there, right? So Elixir, a lot of great things about it, but that's what you're effectively getting to, because Lisp is just saying, it's just changing the data, just changing the code. And so Clojure is a Lisp. Clojure is immutable by default. So you can mutate, but there's a lot of process around it. So it's very specific where you do it, and so it encourages you to push that to the edges. So it's immutable by default, which means it encourages you to do the right things. And then it has reach, right? Clojure is on Java. Clojure script is JavaScript. They have Clojure CLR. There's probably a few other that people work on. But Clojure and Clojure script are the big ones. And it's like, if you can hit Clojure, or if you can hit Java and you can hit JavaScript, you've got 99% of everything covered, pretty much. So I've worked in several different industries, and I've been able to use all of these. And it's extremely stable. Right? It's like when I did the demo for the JavaScript, like I grabbed code that David Nolan, he's the lead developer of ClojureScript. I grabbed code that he had written in 2013 and just ran it. Right? And it was not a big deal. I just grabbed it and just ran it. Right? It's because if you think about it, if you're using a simple language, once you define it, it's just like it doesn't really need to change. Right? So it's built on these really great primitives, and so your primitives don't change, and so you just get awesome stability. And so as I become older and more grouchy developer, I don't want to know your new fancy thing. I want to write my code, I want to serve my customers well, and I want to go home to my wife and daughter. Right? I don't want to learn your new thing. Sorry. Tell me why it's valuable. Oh, that's not valuable. Sorry. Right? It's like, and good or bad, that's how it is. And but then that lets you innovate in different ways, because when you have macros, you can add just really cool stuff that isn't dependent on the language, right? You can write a bunch of stuff in Clojure, a bunch of new macros, and most libraries are actually macros. They're not changes to the language. So part of what that means is you write a macro, and you're like, oh, this is awesome, and then everyone comes out and starts using it, and like, oh, that was a really bad idea, right? Well, what do? Do you deprecate it? Do you do Clojure 2.0 and we break that and so all your code breaks? Or do you say, that's a library, stop using that library? Awesome, awesome stability. Because most stuff is not actually core language, it's just libraries that you're free to choose. And then Clojure loves data. Right? Clojure is built around handling data, and that's most of what I do, and certainly what most developers do, is we really just handle data. And on the edges, we do fancy stuff with the data, we do mutable stuff, right? But most of our stuff is just dealing with data, and Clojure is awesome at it. So yeah, I'm Boston OU on all the stuff, and open any questions. Thanks for listening. Questions? I feel like I was speeding through that, but that was long. What's up?
So you were talking about the serialization, specifically with the data. Could you expand on that a little bit, because it sounds almost like we're putting language semantics over the library.
So you have, so we'll talk about this. So you have that hashtag and then inst. And so what that is called a data reader. And so Clojure has some built-in ones, data's one, UID. And so really what it is just, it's a serialization that everyone has that the language itself has agreed upon. And so what you can do with the date is not represented here at all. Right, and so that's why I say, like, you're not really necessarily putting the semantics of what does the date do. You're just saying this is representative, right? So you can write your own data readers, right? And so, and then that's a way to communicate. But the whole thing is like nothing is going is out of band, right? It's representing the data. So Clojure says, hey, I don't know what an inst is, right? As opposed to, hey, here's the date, and I thought I knew the format, but the format was wrong, right? So it's just clear, it's like, hey, I don't know what this is, and it's like, okay, here's the code that knows how to read this. So there's still gonna be coupling, right, that people have to know what this means, but you're not sending how the code works. You're not sending, hey, when I can add a month to this, right? That's not part of this. This is just I can talk about what this thing is. Is that?
Yeah, I think so.
Okay.
So you had that example before where you showed like it was an HTTP request that was kind of like a map format thing. So,
This one or that one?
well, the first one, it's got all these getters and everything on it, so you kind of have like that documentation that way for like what things you can put in your map, that whatever your code that uses the data cares about. In Clojure, how do you typically like document like, hey, go to the second one?
Okay. I knew I was going to do this. I forgot to repeat the question, so let me repeat this one. All right. So in the Java servlet request, you have some documentation about what is available. So effectively, you have a type, right? And that type is documentation and provides some guards about what can and can't be done. And in the Clojure map, you don't have that. It's just a free-for-all. So that is one of the trade-offs of a dynamic language and of using something that's open like this. I say recently, it's been a couple of years now, they released something called Clojure.spec. And so what it is a specification. And so you can write a specification, and it's code, it's just data, right? And it will run over this, and it can provide specific guards. And so the trade-off, let's start with, the downside is it's not built in, and people are free to use it or free to not. The benefit of it is Clojure, or Rich Hickey has a talk, I think it's called speculation, but he talks about change, and he says change is too broad. We use change like, hey, this file changed, and that really is not precise enough. He says there's two ways that software changes. We either become more restrictive when we break stuff, right? Hey, I said I needed 2 things, but now I need 3, right? Well, everyone that's sending 2, you just broke, right? Or you can grow and accrete, and you can relax, right? I need 2 things. Okay, now I only need 1, right? Well, if you send me 2, your code's going to work, right? So what spec does is it says, hey, this is what should be in the map, right? If you send me more, that's fine, I'll just ignore it, right? Because I may need that later, or I may choose that, you may start sending me more stuff later, and I may choose to use it or may not, but I'm not going to break because you didn't send it. And so I think I might have switched that around. But there's an openness that comes to a map that says you can put stuff in here, and it's not strict, limited by the type, right? And there's a benefit to the limitations of the type, but there's also a trade-off.
So going beyond that, like if you aren't like using that sort of thing, is there any like standard way that people will like document their library, or do you
So,
go dig into the code to see what
so you'll document it by saying, hey, this is the data you're going to get out. This is what's coming in, what I need coming out, and then you'll have things like I didn't show it, but they're called namespace keys. So instead of remote or instead of scheme, you would have request/scheme, right? And so that request would give further documentation as far as what's going on. So that is one of the difficulties of Clojure. Part of what spec is. Sometimes you're just passing maps around, and you're just like, I don't know what this thing is. So a lot of what you'll do is you'll just do destructuring. And so whenever your argument's there, you say, hey, these keys are what I'm pulling out of the argument or out of the parameter, and then that's kind of the documentation as far as when you're working in code. And so it's a trade-off of the openness versus the strictness that tells you exactly what's allowed, but it makes it hard to change. So that's a good question.
It's my understanding that Clojure runs on JVM, is that correct?
Clojure runs on the JVM, correct.
In your experience, how is the interop with like the Clojure and the way you do things in Clojure with like JVM libraries and stuff like that?
Clojure and ClojureScript that is one of the specific things. First of all, it's great. Interop is great, but in both languages. Rich Hickey wrote code for like 20 years and basically said what a lot of us have said, I know I've said it, is either things have to get better or I'm going to go be a farmer, right? Like he's like, I just can't do this anymore. So Clojure was the result of his frustrations and trying to address a lot of frustrations. So it's pragmatic. It's like, this has to be usable. That's part of why it's Java. And people are like, oh, well, I don't like Java, blah, blah. It's like, a lot of work has been into making Java good, and there's tons of libraries, right? So it's not a very wise decision to say, hey, we're going to build on Java, but it's really hard to use any of Java, right? So interop is really good both in Clojure and ClojureScript. Interop with Java in Clojure and interop with JavaScript in ClojureScript. All right. So again, Clojure runs on JVM. So we say Clojure is a host language, also a parasite, or a hosted language or a parasitic language, depending on how you look at it. But it basically takes all the good stuff about Java and kind of rides that. And then ClojureScript takes all the good stuff about JavaScript and rides that. Is kind of how I think about it. Any other questions?
Does that mean you have to know if you're targeting JVM or
Yes. Well, whenever you do something specific to it, yes. So I don't know much about the CLR because I've never actually used that one, but it's going to be the same concept of most of the code. So everything I did with this talk, I pulled up a REPL, which is it's called a read eval print loop. So and I didn't talk about that at all, but you type your code and you can just instantly run it, and there's no like long build process or anything like that. I just pulled up a REPL, and I didn't really care if it was Clojure or ClojureScript because everything is the same that I was looking at. But if I was going to do something like, oh, I want to alert something to the screen, well, that's going to be different if you're talking about Java versus JavaScript. And so when you're talking about like deploying, well, I need to know, am I deploying a jar file or am I just throwing up a JavaScript file somewhere, right? Well, you need to know those things. And so it doesn't hide the fact that you're running on those, but most of your code is just irrelevant which one you're running in.
So do you or can you like pre-compile to JVM bytecode?
Yeah, there's ahead of time compiling. Now, again, most of my work, the way the teams have been split, I've been leading the Clojure script, so I won't be able to speak specifically to that very well, but there's ahead of time compilation and stuff for optimizing. So, any questions? Cool, good questions. I appreciate your time, guys, and thanks for listening.